Hello, my name's Carl Kochar and I'm a technical architect at Microsoft. In this video, we're going to take a look at a direct routing scenario that's based upon a local media optimization configuration with centralized PSTN or PBX connectivity. For some basic calls, I will also show relevant parts of the SIP ladders and Wireshark traces for the resulting media flows. In my lab setup, I have a certified SBC configured for local media optimization. The SBC has a centralized external SIP trunk, SIP connection to the Microsoft Cloud, and a connection to the internal lab network. Alan's Teams client is also on the internal network. The whole idea behind local media optimization is that when Alan makes or receives a call from the outside world, the voice path will exist between his Teams client and the internal IP address of the SBC. For some design scenarios, this will provide improved voice quality as it will minimize end-to-end latency, jitter, and packet loss. In my lab, Joni's Teams client is outside the corporate domain. So when Joni makes and receives calls to the PSTN or PBX, her voice path will exist between her Teams client and the public address of the SBC. In real-life situations, the path to the SBC's public address may actually be blocked by accident or by design. In this case, the media will traverse the Microsoft Cloud's transport relay point to ensure that the media flow between the SBC and Joni's Teams client is always established. Here is a little more detail about the specific lab setup from the Microsoft 365 perspective. For brevity, I've shown the PowerShell commands, but you can also use the Teams admin portal to set up direct routing. The SBC part of the configuration is dependent on the vendor being used. The good news is that every certified vendor provides their own excellent documentation to support this type of configuration. One of the key system configuration elements is the trusted IP address, as this is used to identify whether a Microsoft Teams client is inside or outside the corporate network. The rest of the network configuration builds up a logical topology of IP subnets, sites, and regions associated with the organization's internal network. From the Microsoft perspective, the important local media optimization configuration parameters for the SBC are media bypass, bypass mode, and the Proxy SBC settings. Defining media bypass as true enables media optimization. Bypass modes enables the additional Microsoft SIP headers that are used to convey the location of a Teams client. We will see these in action later on. When bypass is set to always, this means that the internal IP address of the local SBC will be offered for every internal call. In our lab, we have a central SBC with centralized PBX breakout, so the proxy SB setting is set to null. Alternatively, it could be set to the fully qualified domain name of the SBC. Although not demonstrated in this video, direct routing can also be used to provide external access to the Microsoft Teams auto attendance, and call queues. In this first calling scenario, my internal Microsoft Teams user Alan rings James, whose phone number is accessible via direct routing. When we review the first SIP invite from the Microsoft Cloud, we can see the new XMS headers that inform the SBC that this call is from inside the corporate network and which site it came from. The headers also provide the fully qualified domain name of the target SBC to route the call to. In this instance, it's the local SBC. The SDP also contains all the ICE candidates available to establish the media path. These include the local UDP host address of the Teams client. As the call has been categorized as internal, the SBC returns its internal IP address 10.3.0.6 as the ICE candidate. The rest of the call setup signaling now just contains the Teams clients and SBC's local IP addresses as the ICE candidates. When we look at the Wireshark trace on Alan's computer, we can see that the voice media flows within the internal network between Alan's Microsoft Teams client and the SBC. Now, when James makes a call to Alan, the resulting media path will ultimately be the same, but the signaling will be different. As the call originates outside of the Microsoft domain, there are no XMS headers in the initial invite, but note that the SBC does offer its internal IP address as the ICE candidate. In the Microsoft response, the XMS headers inform the SBC this is an internal call and offers a range of ICE candidates, including Alan's internal host IP address. Then the rest of the signaling ensures the local media path is established. When we look at the Wireshark trace on Alan's computer, we can see that the voice media flows within the internal network between Alan's Microsoft Teams client and the SBC. In this use case, Joni, who is working outside of the organization, uses direct routing to call James. In the first incoming invite, we now have two XMS headers, one showing the call has come from an external location and the other identifying our local SBC as the target. As was the case with an internal call, the SDP includes multiple ICE candidates, including Joni's host IP address and also the reflexive public IP address of Joni's Teams client. Because the Microsoft Cloud has told the SBC that Joni is on an external network, the ICE candidate provided by the SBC is that of its public IP address. This then allows the media path to be set up between Joni's client's public reflexive IP address and the public IP address of the SBC. Because the Wireshark trace has been taken on Joni's client, we see the RTP stream using her local private network address to talk to the SBC. When we dial from James to Joni, we can see that the ICE candidate from the SBC is switched from its private IP address to its public one after receipt of the XMS headers marking the call as external. The rest of the SIP exchange ensures the media path is set up between Joni's client's public reflexive IP address and the public SBC address. If for any reason access to the public IP address of the SBC is blocked, then the media would flow via a transport relay IP address offered as one of the team's candidates. The Wireshark trace from Joni's machine verifies that the RTP stream flows between Joni's client and the SBC's public IP address. In this video, I have concentrated on the direct routing local media optimization scenario that provides centralized SIP trunking for an enterprise. However, local media optimization also allows you to build a virtual network topology of SBCs, where the SBCs in the local branch offices are connected to a centralized proxy SBC that is visible to and communicating with Microsoft phone system through its external IP address. In this network topology, downstream SBCs are communicating through internal IP addresses and are not directly visible to phone system. This diagram depicts an example of one such deployment scenario. For further details, please refer to Microsoft's Local Media Optimization for Direct Routing Planning Guide that's published on the web. So to summarize, the reason for deploying these types of local media optimization topologies is to keep media local within the boundaries of the corporate network. In some enterprise scenarios, this is desired behavior, as it does allow organisations to manage their voice quality.